Guys, do we remember what probability is actually all about? What is probability? What does it mean? The chance of something happening. All right? It's like a broad answer. That's what I was looking for. So basically, in grade 9, you were meant to learn that there is theoretical probability, and then there is, what is the actual thing called again? Theoretical probability is what we expect is going to happen, right? So when you are tossing a coin or flipping a coin, say you're flipping that coin 10 times, we expect that coin to land on heads 5 times and on tails 5 times, right? Does that make sense? Because it's 1 out of 2 chance. But in reality, maybe you are flipping a coin 10 times and maybe it lands on heads 7 times and on tails 3 times, right? That is the experimental probability. That is what actually happens when you are actually doing an experiment, okay? Theoretical probability is what we work with in grade 10. In grade 9, we worked with both. Grade 10 is only theoretical probability going forward. Okay, so I'm just going to write the formula down here, and maybe you also just want to copy it down. So the probability of A, we do use this kind of notation. We do a capital P, and then in brackets, we write whatever the event is, right? So if we're tossing a coin and we're looking for the probability of it landing on heads, we would put heads in the brackets. Okay, whatever the event is, depends on the question. Now I'm going to introduce something slightly new. Some of you might have seen this last year. Some of you, oh dear, some of you might not have. Let's see, try that again. There we go. So the probability of A is N of A over N of S. Now what do we think N stands for? Number. Okay, so what this means, guys, is the probability of A, the event, so whatever they're asking you about, is the number of outcomes in event A. We'll do an example now so that you can see exactly what that means. And then the S is probably new to most of you. The S stands for sample space. So N is the number of, or N of S is the number of outcomes in the sample space. Now the sample space is basically all of the possible outcomes that you can get. So if you are rolling a die or a dice, how many possible outcomes are there altogether? How many numbers are there on the die or on the dice? 6. All right, so the sample space would be the 6 numbers. 1, 2, 3, 4, 5, 6. Okay. We're quickly going to just do an example. So if we are asking here, for example, when rolling a 6-sided die. Sometimes they say die, sometimes they say dice, either way. What is the probability of it landing on an even number? Now guys, if you are looking at your textbook, they are working with curly brackets quite often. It's called set notation. So I just want to explain to you what that means, where that comes from. So let's use an E to represent this event, right? Does that make sense? Because it's even numbers. Is it fine if we use an E for that? Okay. So what they would do in the textbook quite often, and you don't have to, I just want you to know what they're talking about if you see it. They will use a letter to represent the event, and then they would list all of the numbers that now fall in that event. All right, so if we're thinking of a 6-sided die, it's 1, 2, 3, 4, 5, 6. Those are the numbers, right? Which of those numbers are even numbers? 2, 4, and 6. So what you do is you use a curly bracket, right? That kind of bracket, it looks like that. And then you would list the numbers. So the 2 and the 4 and the 6. You separate them using a semicolon, and then you close your bracket. Okay, so this is the set of E. And we can just write that on the side. So if they're asking for set E, then you know you need to write it in that notation. Now S, we can always use S to represent the sample space. The sample space is all possible outcomes. So when we are rolling a die, we have 1, 2, 3, 4, 5, and 6 as our sample space. That's not a very nice looking bracket. Let me just fix that one. Okay, so this is the sample space. If they didn't ask for the sets, you don't have to write that down. Okay, if they've just asked for the probability, you can just go straight to the answer. I just want you guys to see, yeah, maybe they add that into the question and then you would have to. All right, so now we're going to say the probability of E, or if you want, you can just say probability of even, the word even, that's also fine. Now, how many numbers are in set E? How many even numbers are there? 3. Over, how many numbers are there in the sample space? How many numbers are there altogether? 6. But guys, am I correct in saying you don't actually need those two things written down to be able to get to the answer, right? We did this last year. You just ask yourself, how many even numbers are there? 3, so that goes at the top. How many numbers in total? 6, so that goes at the bottom. Am I allowed to leave my answer like that? No, never. Okay, you always have to simplify your answer, even if the question doesn't say that, guys. It goes without saying. Okay, you have to simplify your answer always to a half. You can even go straight to a half if you want. All right, you don't actually have to write 3 over 6 first. If you can do that in your head and then just write a half, that's also fine. But you have to write a half. Okay, so you will get a mark for that and then a mark for the simplified answer. Okay, any questions so far, guys? Just want to take a look here quickly. So that's kind of like the basic thing that you did last year. You also drew tree diagrams last year, which we do still need to know how to do. Do we remember that? With the kind of branches coming out. Now, I want us to think about, let me just quickly see. Can I do a little star there next to that one? Because now I'm going on to another part of this note. Okay, replacing versus not replacing. I'm just going to write an example and then we'll talk about it. There are 5 red sweets and 2 green sweets in a bag. A sweet is chosen at random. Eaten, right? I'm guessing that's why you're choosing the sweet. So you're taking it out, you're eating it, and then a second sweet is chosen. Okay, we are going to draw a tree diagram to represent this. Alright guys, when you are doing a tree diagram, and usually we're only going to use tree diagrams to represent multiple events. Okay, if it's just one sweet being chosen, I don't think we need a tree diagram for that. Okay, let's quickly think about it. If we were just choosing one sweet, how many sweets are there altogether in this bag? 7. How many red ones? 5. So if they're asking what the probability, if they're asking for the probability of drawing a red sweet, it would be 5 over 7. Right? You don't need a tree diagram for that. Okay, you just need to know how many red sweets we have and how many sweets in total. Same thing for green sweets. If they asked, drawing one sweet, what is the probability of drawing a green sweet? You would say 2 over 7. Okay, but now because there are 2 sweets being chosen, we call this a compound event. We can add that here next to the heading. Because this issue of replacing versus not replacing only comes in when we have multiple things happening, multiple events. So a compound event. Alright, so now it can be useful to draw a tree diagram. But guys, in a test or exam, if they don't say specifically draw a tree diagram, you actually don't have to. Okay, you can also just kind of figure it out in your head. I'll show you how to do that just now. Alright, so for this tree diagram, we're going to draw one set of branches to represent the first sweet being chosen. And then we're going to draw a second set or second sets of branches, you'll see, to represent the second sweet being chosen. Okay, so how many events are taking place? 2, so we're going to draw 2 sets of branches. Okay, so now you're going to take a ruler, please, and we're going to do 2 lines because there are 2 types of sweets. If there were 3 types of sweets, guys, if there were red, green, and blue sweets, for example, we would draw 3 lines. Okay, so 1 line for each type of each outcome, I suppose. All right, so 1 line for each type of sweet. So I'm going to use an R to represent red and a G to represent green. Okay, what is the probability of drawing a red sweet? We said there are 5 red sweets out of 7 in total. So guys, on a tree diagram, you always have to put the probabilities on the branches as well. So there is a 5 out of 7 chance, or 5 in 7 chance, 5 over 7 probability of drawing a red sweet, and 2 over 7 of drawing a green sweet. Guys, very important on a tree diagram. Thank you. The probabilities on one set of branches are meant to add up to 1. Okay, so this 5 over 7 plus 2 over 7 should give you 1. Let's just write that there. 5, sorry, I want to make it a bit smaller. 5 over 7 plus 2 over 7. Guys, that will give you 7 over 7, right? Which is 1. If your numbers don't add up to 1, you've done something wrong. Okay, they always have to in one set. Okay, now when we are drawing the second sweet, right, there are 4 things that could happen, all right? The first sweet can be red and the second sweet can also be red. That is one possible combined outcome of this whole thing, right? Both sweets that I draw are red. Or if my first sweet is red, the second one can also be green, right? So this is another combined outcome. First sweet red, second sweet green. Or if your first sweet that you drew was a green one, the second one can be red. Right? So that is the third combined outcome. First sweet green, second sweet red. Or both sweets that you are drawing from this bag could be green. So guys, you have to always draw a set of branches from each of the first outcomes. Okay, there are some questions where you are not going to do that. We can look at an example. But most of the time, you are going to draw the same number of branches from each first branch, if that makes sense. Now we need to put the new probabilities on these second sets of branches. Now this is where it becomes a little bit more complicated. Because now, guys, if my first sweet was a red one, right? What did I do with that sweet? I ate it. So are there still 5 red sweets in that bag? No, there are now only 4. And how many sweets in total? 6. Now here, guys, you can simplify this to 2 over 3, but you are actually also allowed to keep it as 4 over 6. Okay, in a tree diagram, it's the only place in maths ever that you are allowed to leave your answers, your fractions, as not simplified. Okay, so in a tree diagram, you don't have to simplify it. I'm just going to make a note here. You can simplify if you want to, but you don't have to. Okay, now, green. If the first sweet was a red one, are there still 2 green sweets in the bag? Yes. And now there are not 7 sweets anymore, but 6 in total. So again, 2 over 6, you can leave it like that, or you can simplify it to a third. It's up to you. Okay, now we're going to do the same thing for the second set of branches here at the bottom. But now, guys, the first sweet was green. Okay, so we're following what the first branch is telling us. That is what happened in the first row. Okay, so if my first sweet was green, how many red sweets are left? 5, right? Because there were 5 to begin with, and now I've taken a green one. So there are 5 sweets out of 6 in total. And now if the first one was green, there were 2 green sweets originally. Now there's only 1, right? So 1 out of 6. Guys, just check. Do these pairs of probabilities add up to 1? If I have 4 over 6 plus 2 over 6, that is 6 over 6, which is 1. Okay, I'm going to write it here at the bottom. 4 over 6 plus 2 over 6 is equal to 1. And then for the second set here at the bottom, 5 over 6 plus 1 over 6, that is also equal to 1. Guys, can we focus, please? Alright, so those all work. Now the last thing that you please need to do is you need to list your final outcomes just on the side of your tree diagram here. So we're just going to write down red and red. So you can write RR if you want. If you had written the word red and red, then you would just say red and red. It's up to you. It doesn't really matter. For this one, we would say red, green. Then we would say green, red, and then green, green. Yeah.
May I just ask, if you get this in the test, do you have to write all the, 5 over 7 is plus 9 is equal?
Oh, no, you don't have to.
Is that true? Okay,
Yeah. It's just a part of the note. Yeah. Alright, guys, so that is the tree diagram. You did do this last year, but I thought it would be good if we just revised it. Now, what if they said you're taking out the sweet and then you're putting it back? Would these probabilities change from the first ones? Then your probabilities would be the same all the way through, right? So you would have 5 over 7, 5 over 7, 5 over 7. You would have 2 over 7, 2 over 7, 2 over 7. Okay, so that is when they say the sweet is replaced. They usually use that term. Okay, which doesn't make sense, but yeah, sometimes they put that in the question. Okay, number 2, we're just going to quickly calculate some probabilities from this tree diagram. So question 2. Alright, so calculate the probability of red, red. So that means a red sweet and then another red sweet. Guys, I want us just to note here that this is an AND question because we are going to talk about an AND question versus an OR question. They didn't use the word AND, but I could have, right? I could have written in words, calculate the probability that both sweets are red. Does that make sense? First sweet red and second sweet red, right? Both are red. That means that it's an AND question. Now what we're going to do for this is we are going to look at our tree diagram and we are going to take the probabilities leading up to that final outcome of red, red. And what are we going to do with those probabilities? We're going to times them. We're going to multiply them together. Guys, that is what we always do when it's an AND question. Okay, we are going to write it down as a note as well. But for and, we are going to multiply. So we are going to say it is 5 over 7 times 4 over 6. So that is going to give us 10 over 21. Is that correct? Just check quickly because this is a third. Yes. Oh, 5 over 21. Oops, sorry. Not starting off on a good note. 5 over 21. My apologies. You can obviously use your calculator for that as well. Now, guys, if we didn't have a tree diagram, we still need to be able. Yes.
4 over 6 is not.
It's 2 over 3. Oh, guys. Thank you. Oh, no. You know what? I was testing you. First day back. Let's test Miss Hanekom, actually. I was testing myself and I failed. Sorry about that, guys. All right. What was I saying? Oh, if we don't have a tree diagram, we need to actually be able to answer this question without drawing a tree diagram. Because in a test or exam, especially now because you're in grade 10, a question like this could count 2 marks. And then do you want to go through all of the effort of drawing this whole tree diagram and doing the multiplication just for 2 marks? That's a bit much. Okay. So going forward, what I want you to do is only if the question says draw a tree diagram, do you have to draw one, right? If you want to, if you have a lot of time and you think, oh, it's going to make it easier for me to actually draw the tree diagram, especially in the beginning when you're getting into this work, feel free to do it. But in a test or exam, by the time that we get to that point, I want you guys to be able to do this type of question without drawing a tree diagram. So what you're going to do is you're going to say, firstly, you need to know what is the probability of drawing red first. And then the second thing that you need to do is why did I put an R there? Oh my word. The second thing that you need to do is you need to find what is the probability of drawing a red second. And then because it's an and question, you are going to times the 2 probabilities together. So this is now instead of drawing a tree diagram, right? Coming up with those probabilities in your head by understanding the question, hopefully, and then multiplying them together. So guys, what is the probability of drawing a red one first? How many sweets were there? 7. How many red ones? 5. So this would be 5 over 7. Then you must be very careful because now, remember, you ate the first one, right? You ate the first red one. So now how many red sweets are there in the second drawer? 4. Out of how many sweets in total? 6. 4 over 6. And then you will times those together. So actually, guys, in a test or exam, you should be able to do all of that without drawing your tree diagram. Okay, just by knowing the probability of a red sweet first, multiplying that by the probability of a red sweet second, and then getting your answer. Okay, so we need to try to work on that going forward to get to those answers as well. Let's quickly do the probability of 2 green sweets. Now guys, 2 green sweets, that again is an and question because it is the first sweet is green and then the second sweet is green as well. So I'm going to write underneath again and what I'm also going to do here is I'm just going to highlight this times and the and there. Right, for an and question, we are always going to times. We're going to multiply. So now let's try and do this without actually looking at our tree diagram. I know we have a tree diagram, but let's try and do it without. What is the probability of drawing a green sweet the first time? 2 out of 7. There were 2 green sweets, 7 in total, right? So we're going to say 2 over 7. Because it's and, we're going to times that by the probability of drawing a green sweet again the second time, which was what? 1 over 6. 1 less, right? Because the first one was green and then we ate it. Okay, now let me just be very careful here. I'm going to cancel out here. I'm going to do a 1 and a 3. Is that right? So I'm going to get 1 over 21. And again, I'm just going to highlight this times because the times comes from it being an and question. Okay, now for C. I don't really have enough space. I'm going to do it next to this one. So C is the probability of red, red, or green, green. Now, the way that this question could have been worded if they wrote it like in a sentence, not with the symbol here, is if they said, drawing 2 sweets of the same color. So if they said in words, calculate the probability of drawing 2 sweets of the same color, but they're not specifying which color. Do we agree that it could be either 2 red sweets or 2 green sweets? Okay, so this is an or question. Oh dear. Guys, I'm not doing well. This is an or question, all right? And what we do with an or question is we are going to add together. Okay, so now what we're going to do is we are going to, and I'm just going to write down this kind of broken up. We're going to do the probability of 2 red sweets, and then we are going to add the probability of 2 green sweets. So the or is adding. Okay, like I said, we'll write that down as a note as well. And now, guys, we've actually already calculated these 2 separate probabilities, right? We know what the probability of 2 red sweets is. What is that? 10 over 21. That was the answer to my first question. So we're going to say 10 over 21. And we are going to add the probability of 2 green sweets. So that is going to be 1 over 21. So my answer is going to be 11 over 21. Guys, if I had not yet calculated red, red, and green, green, you would have to first do that. Okay? And you could do it in brackets. So you could, in brackets, say 5 over 7 times 4 over 6 plus 2 over 7 times 1 over 6, and then get your answer. Okay, if you hadn't already calculated those. Does that make sense, guys? And is times and or is plus. Okay, I want us just to quickly write that down as well, as a note. But I think you did do questions like this last year. Now we're just kind of trying to formalize formulas so that you don't need a tree diagram, so that you can just do it using the probabilities. Okay, so the next heading that I'm going to do is I'm just going to write and or statements. So are you all done copying this down? That was a big sigh. Does that sign mean yes? I'm going to go with that meaning yes. All right, so let's say... It's a and versus or statements. All right, so first one. Thank you. Let's focus, please. The probability of A and B is equal to the probability of A multiplied by the probability of B. So again, I'm just going to highlight the and then the times. Then for or, we are going to say the probability of A or B is equal to the probability of A plus the probability of B. But now for the or, there is just one extra thing, which, yes, we'll do an example. So let me just add here, but if the two events overlap, and what I mean by overlap is basically if they have 1 or 2 or 3, however many numbers that are in both events. You'll see now when we do an example. So I'm going to write here, have elements in common we have to subtract those elements. So then our formula here is going to look slightly different, and like I said, I'll explain now with an example. The probability of A or B is then going to be the probability of A plus the probability of B minus the probability of A and B. We'll show you now where that comes from. Now guys, this actually is called the probability identity, and you're going to use this all the way up until matric. They are, quite often they test this identity in matric, so I'm just going to write underneath this. This is the probability identity. Let's quickly look at an example. So determine the probability of getting an even number or a number less than 3. Now guys, for this, you can actually do this question just by thinking about it. You don't have to use the probability identity. I just want to show you how it works. Okay, so can we just quickly think about that? If they're asking for the probability of getting an even number or a number less than 3, what numbers would that then be? Does one work? Is 1 even or less than 3? It's or, right? It doesn't have to be both. If they wanted both, if they wanted a number that is even and less than 3, they would say the word and. Okay, so or 1 falls into that category because 1 is either an even number or it's a number less than 3, right? It's less than 3. What about 2? Is 2 even or less than 3? It's actually both. Okay? And then what about 3? No, because they're saying less than 3. They're not saying less than or equal to 3. And 3 also isn't even. Okay, so we have 2 so far. What about 4? Remember they're saying even or less than 3. So it's okay if it's not less than 3 as long as it's even. Okay, so 4 works. What about 5? No? 6? Yes. So there are 4 of the 6 numbers that fall into this category. Okay, so the probability that we're going to end up with is going to be 4 over 6, 2 over 3. But let's quickly see if it works if we use the probability identity as well. So I want us just to do our sets again. Let's list the sets. So let's use E for even. So the even numbers are 2, 4, and 6. And then for less than 3, what letter? Let's use an owl, I guess. It's 1 and 2, right? Those are the only 2 numbers that are less than 3. Guys, do we notice that we have 2 in both of these sets? So 2 is the overlap, right? 2 is the element that is in common. So guys, remember we said that we're supposed to have 4 over 6, right? Do you remember? That's the answer, 4 over 6. If I just say, okay, this is an OR question, so I'm going to add the 2 together, I would get 3 plus 2, I would get 5, right? But we need to get to 4. The reason why we would get 5 is because I'm counting 2 twice. I'm counting 2 as an even number, but then I'm counting it again as a number that's less than 3. But actually 2 is just one possible outcome. Right, so I can't count it twice. So because I've counted it twice, if I were to add them together, I would have to subtract it again. Okay, so let's quickly just write this down. We're going to say the probability of E or L would be, if we're now applying the probability identity, which is up there at the top, it's OR, so I'm looking for this identity. I'm going to say the probability of the first event, even, plus, because remember for OR we always add together, probability of L. But now because the 2 events overlap, because they have an element in common, I have to subtract that element that is in E and L. The element that is in common there. So this E and L is that 2. So that is the one that I'm subtracting. Because I've added it twice. What is the probability of E? How many outcomes are in E? How many numbers? 3. So we're going to say 3 over 6. The probability of the die landing on an even number is 3 over 6. Plus, what is the probability of the die landing on a number that is less than 3? 2. 2 over 6. But now, because there was one number in common, we need to subtract that number. So guys, what is the probability, just listen to what I'm saying, of the die landing on a number that is both even and less than 3? How many numbers are there that are both even and less than 3? Only 1. So that probability is going to be 1 over 6. So then we end up with our 4 over 6, or you can go straight to the answer, which is 2 over 3. Okay, so this is something that's new, guys. OR is you adding together, but now you also need to think, do the 2 events actually overlap? All right, is there a number, or maybe there were 2 numbers, however many, that lie in both of those options? Is it possible for the die to land on a number that is both even and less than 3 at the same time? Yes, then you must subtract it. Okay, I just want to, I think, highlight this identity here because it is important, and we're going to practice it a lot. So if you're still feeling a bit iffy about it, don't stress just yet. I want you to do an exercise. It is on in the note that's in Google Classroom, but I'll also put it on the board quickly so that you can see it. So I'm just going to write here homework, and you can do it now. you have 11 minutes still of this lesson. So it is exercise 2, page 4 on Google Classroom. And this is in the probability note, so you must just go to classwork and then look for it there. Okay, have you all copied that down? I just want to put it up on the board for you. Alright, that is exercise 2. It's those 3 questions. Let's see if that helps. And basically you're going to have to think of just probability, like the formula, the number of events over, or number outcomes in the event over the number